All right, I'm going to walk you through a regression analysis one more time. This time we're going to check for normality, or that we do not violate assumptions, okay, specifically of homoscedasticity. Okay, we're going to check a few things. So we talked about that in lecture. So I've already set this up once. So we're using psychological reactance as our dependent variable. That's the reaction people get to suggestions or requests that they do something feeling like they're going to lose their freedom. It doesn't really matter. And we're now moral agency or perceived control over morally relevant behavior as our predictor variable. Okay, we can select descriptives, as I've told you before, for our statistics, and then we go to plots. Okay, and what we're going to do, this is the way this looks before we do anything, right? Okay, we are going to put in our x-axis our predicted values, okay, of y, and here we're going to put in our y-axis our residuals, okay, that z residual, okay, and then we're going to select normal probability plot, so PP plot, all right, hit continue and okay. All right, so we're going to get our usual output, okay, just as a reminder, we have our descriptives, mean and standard deviation of the two variables. We have our zero order correlation, which is negative 0.16, which is statistically significant, but this is a huge sample, so practically anything is going to be statistically significant, right? This is just for demonstration. We have, as usual, our ANOVA table with our sums of squares, residual, error, regression, and total. Then we have our coefficients. So we have our intercept, which is 3.62, our slope, which is negative 0.21, right? And our standardized, which is the same as our correlation coefficient, right? Okay, we have some statistics, which for this course, we're not going to worry about. And then we have our PP plot. Now, this is pretty much ideal. So there is a line here. And ideally, you want all the dots, okay, your expected cumulative probability by observed, all the dots to line up alongside that line. And they really do. Okay, it's usually not this perfect, but this is a big data set, right? And then we get to our scatter plot. So we have predicted values and our standardized residuals. Okay, that's the difference between the predicted and the actual data, right? And what we want here is we want something that's pretty much equal first of all, fairly equally spread around zero all along the different values, right? So we can double click this to better visualize it. And we can add a low S line. So we click on where we add the regression line to plots, right? And we select low S, okay, apply, close. And again, this is pretty much what we want to see. We want this line to be pretty much right along zero, which it is for the most part. And we want the spread to be equal on both parts. Now, it's not perfect. We can see there's just these few values up here that are higher. And this one like kind of way out here. But more or less, this is a good flat line right along zero with the spread fairly equal across it. So that's how you check. This would be checking for homoscedasticity. If it were hetero, then these would be all, there'd be some kind of a pattern here. It might be really spread apart here. I mean, it's a little bit, but not really here. And again, for normality of residuals here. So this looks pretty good, and that's how you would check. You won't have to do that for this course, but it is related to the lecture, so that's why I've shown you how to do it.